After knocking a hole in the wall, the camera is inserted, then rotated 360 degrees, searching the darkness for survivors. The camera allows one rescuer to quickly survey a damaged building instead of putting many rescuers at risk. In a disaster, the call to duty can be a dangerous one. For those who answer, there is one powerful reward: knowing they've helped a fellow human being.
I know that there's someone that needs my help, and if my family was in a situation like that, I think that the people would do the same for me.
Get in the back of the camera. Forward.
I found out that every single experience in my entire life could be brought to bear to make me more successful at saving lives. I knew why I was put on this earth.
The earth can shake anywhere, anytime. Where will rescuers be called next? Tokyo, population 11.5 million. It is the super city of Japan, a financial mecca. A place where real estate prices soar as high as the skyscrapers that crowd the landscape. It is also an earthquake time bomb waiting to explode. As many as 1,000 earthquakes strike Japan each year. But none so devastating as the earthquake that struck Tokyo in 1923. It was the most damaging earthquake in the history of Japan. The quake and the fires that followed nearly decimated the city. More than 140,000 lives were lost. In one horrific incident, a blaze swept through an officially designated safety area, killing 38,000 people. The disaster left 7 square miles of Tokyo in ruins. Today, most experts believe that another large earthquake could hit Tokyo at any moment.
Tokyo is at very high risk in the next few decades. If we have a massive earthquake in the heart of Tokyo, we're going to see devastation like we've rarely seen in this century. You could have perhaps 20 times as many people killed as in Kobe, where there were 5,000 people killed.
Charles Scorthron is an engineer who lives and works in Tokyo.
What we're talking about here is people and buildings and infrastructure equivalent to the state of California compressed into an area roughly the size of Los Angeles. Much of it on poor soils, sitting on several major earthquake faults.
Earthquake preparedness films like this one hammer home the danger. The worst-case scenario is an earthquake that strikes Tokyo on a weekday afternoon when thousands of people are at work. Buildings that do not meet current seismic codes would suffer damage or collapse. Roads and bridges would crumble. And fires, 4 times as many as in Kobe, would burn out of control, reducing much of Tokyo to ashes. The danger that threatens Tokyo lies beneath the ocean. Off Japan's coast, 4 of the Earth's plates are thrusting beneath each other, spawning violent earthquakes and volcanoes. In California, geological forces building along the San Andreas fault line also threaten to rupture in a devastating earthquake. The last time a severe earthquake happened was in San Francisco 1906. The earthquake was one of the strongest ever recorded in California. Buildings that didn't crumble from the shaking ignited in flames as fire swept across the city. The disaster left hundreds dead. If another big earthquake were to strike on the San Andreas, the death toll could climb into the thousands.
We know there will be an earthquake close to magnitude 8 on the San Andreas Fault in Southern California. We don't know exactly when. Chances are it'll be before we die. Are you setting up the...
Dr. Lucy Jones is a geophysicist who lives and works in Southern California.
Los Angeles is about 10 feet closer to San Francisco than it was when LA City Hall was built. It's moving, and it's stuck along the San Andreas Fault. We can measure that. And at some point, they're going to have to catch up with each other.
In the last 10 years, California has had a run of earthquakes. They've rattled more than nerves, but none has been the big one. When the magnitude 8 strikes, make no mistake, it'll be the worst earthquake California has seen in almost a century.
Fire department! We're going to have a lot of fires. We're going to have a lot of people injured, many people killed. Overpasses will be down. Roads will be buckled. Emergency services will be tasked and expanded to their limit. There's no question. You take Northridge and you times it by 100, and you look at a widespread area, and that's the kind of devastation that you're going to see.
It may sound like a doomsday scenario, but it is a scenario based in fact. Geologists have unearthed evidence that the San Andreas Fault produces a major earthquake, on average, every 130 years. As time passes, the risk increases.
Earthquakes occurred in 1857, magnitude 8, 1812, 1480, 1350, going all the way back to about 500 AD. So we've actually gone past, by 10 years, the average interval.
But the San Andreas isn't the only threat. Directly beneath Los Angeles is a network of smaller faults that could unleash an even greater disaster.
Many of us geologists now believe that, in fact, there are good reasons to believe that a 7.5 really is possible within the downtown, in the metropolitan region.
A 7.5 in the city is going to be more devastating to Los Angeles than the 8 on the San Andreas Fault, because we are right by that shaking. It'll be directly underneath our big buildings and our freeways. The good news is they happen less often. The bad news is they definitely happen.
In the quest to predict when the quakes will happen, the Chinese look to the animals. When will the next big earthquake strike? Some say trying to predict it is like trying to predict the exact moment lightning will bolt from the sky. It's a question that seismologists have debated for decades.
To be able to predict an earthquake, you would have to have, one, that something happens before the earthquake can begin, like the magma moving to the surface in a volcano. In addition, whatever that something is would have to be different for big earthquakes than for small earthquakes.
At the California Institute of Technology, a network of seismometers keeps track of the earthquakes in the state. The shaking is then broadcast over a system called Cube.
Every day in California, we have earthquakes. We have never had a day that there was no broadcast over Cube.
And this day is no exception.
Okay, what we just had is a magnitude 2.0 occurring 5 miles northeast of Santa Monica, 4 miles south-southwest of Hollywood.
In the next 10 years, the network could serve as an early warning system, giving the public a minute's warning before an earthquake shockwave strikes. But the ability to make longer predictions isn't in the forecast.
In seismology, number one, we don't know what makes an earthquake start, and we don't know what makes it stop. We're still trying to figure out some very big fundamentals.
At the heart of the puzzle is one overriding question. When the ground moves, does the Earth send out some sort of signal beforehand? In China, they believe it does. For centuries, the Chinese have had their ear to the Earth. Nearly 2,000 years ago, they invented the first earthquake detector, a bowl with an instrument inside that drops a ball from a dragon's mouth at the first sign of a tremor. The Chinese were also first to predict an earthquake.
Every earthquake is unique, and so every earthquake has its own particular characteristics.
Jean Chu is an American scientist working for the Chinese government. She has researched one of the most famous earthquakes ever predicted, China's Haicheng earthquake of 1975.
The Haicheng earthquake had a whole series of precursors, and I actually asked the earthquake scientists in the province who had monitored and predicted it, and they said if it hadn't been for the whole series of signals, taking one on its own would not have convinced them to alert the community.
For months, the Chinese monitored the environment. They noticed odd phenomena, like snakes coming out of hibernation, and other strange animal behavior as depicted in this government film. But more significant was a series of foreshocks that happened just before the earthquake struck. On February 4th, 1975, a strong tremor hit Haicheng. The city was completely shattered, but relatively few lives were lost. Because experts had predicted the earthquake, the people were warned hours in advance. 1 year later, residents of another city, Tangshan, would not be as lucky.
In Tangshan, there were also a series of signals that the Earth gave out. And they were monitoring those signals, but they were also looking for seismic signals, which the Tangshan earthquake did not have.
The earthquake struck without warning, virtually obliterating Tangshan. $250,000 people died. It was one of the most devastating earthquakes in history.
Only about a third to a half of earthquakes are preceded by foreshocks, and Tangshan was not one of them.
Intrigued by the prediction efforts in China, Dr. Jones made research trips to the country during the 1980s. She came away disappointed.
It's a mistake to think that because there is a prediction before one event means that you'll always be able to predict the other ones. How can we predict them when we don't know what's the process that causes them to occur?
We may never be able to predict exactly when the ground will move. It's a secret the Earth refuses to give up.
Okay, ready? Got it?
But geologists are uncovering information that can help us live with the inevitability of an earthquake.
If we know how often a fault moves and how large the earthquakes are, we can help design buildings better to withstand earthquakes.
By examining the Earth in intimate detail, geologists have come to realize how natural and frequent earthquakes are.
So, Carrie, for these offsets of 5 meters, it's kind of like a death.
They may not be able to predict quakes precisely, but they take pride in what they have learned.
You could show somebody that a fault is likely to go in 50 years, and as a result, all kinds of preparations are made and 100,000 lives are saved. You know, imagine the way you'd feel about that when you're 70 and it happens and people's lives are saved. You know, it's a tremendous challenge to try to do something heroic.
Earthquakes are an